while we are waiting for that, I just wanted to ask something.
Go for it!
The spaceship, the force, the equivalent.
Oh yeah, I should do that one. Oh no, that's not the spaceship. Yeah, go on.
Yeah, and I have two answers.
Yes.
Interesting.
No. Two answers is possible because it's quadratic.
Yeah.
But I think both answers actually could make sense, but it's the smaller answer you would want, because you want the answer which is here. But there may be some answer over here in which the pull between the Earth and the Moon is the same. But this is not quite the point I want, because I was looking for specifically a point in the middle. So yeah, you're right, two answers is possible here. And this answer is a lot bigger than this answer. So this one must have the spaceship here, where the pull of the moon is smaller but closer. That balances the Earth, which is bigger but further away. That is interesting. I think the problem didn't happen when I did it because I never considered the plus and minus in my square root. But if you do consider it, you get a second answer. Yeah. So no, it's good. Very good. Okay. Continuing. So what I want to do, I want to first start by doing that homework question I left you, and then we'll have a look at a bit more fields. You okay? Cycled super fast? No? Walked super fast. Okay. Can you remind me of the information, please, that I gave you? It was a +5 and a -3 coulomb, not microcoulombs. Was it like this, guys? 20 centimeters? 3 electrons. So, I want to know where I should put this. And really, I have to consider 3 scenarios. The first one is that the 3 electrons are here. Or maybe they're somewhere here. Or maybe they're somewhere here. Let's see which ones are possible and impossible. Firstly, could this one be possible? Well, let's see. This will be pulled towards the positive and pushed away from the negative. So it could never be balanced in the middle region. Could it be balanced here? It'll be pulled towards the positive and it'll be pushed away from the negative. Is this possible? Well, it's being pulled towards the positive, so this will be quite big because it is both close to the positive and the positive is quite large. This will be quite small because it is quite far away from this and it's smaller. So it seems not likely. Now, if you wanted to, you could actually do this and see that you don't get an answer, but it seems quite likely that this is not it. Well, let's look at what's happened here. It will be pushed away from the negative, and this will be quite large because it is both close. Well, it will be pushed away, but also it will be pulled towards the positive. Now, although the positive is further away, it's actually bigger than this. So in total, this could be large as well. Or at least they should be equal. So I think this is where we need to look for balance in it. So we'll call this distance here x. And we know that x should be bigger. No. Let's actually call this distance here x. And x should be more than 0. Right, so the two forces are... Firstly, we'll do the negative force here. So that would be K, Q1, which we'll say is -3 times 10 to the -6, times Q2, which is 3e, all over x squared. And that should equal K You know, I won't worry about the minus because I'm making them equal here in size. 5 times 10 to the minus 6 times 3e, yeah, all over 0.2 plus x squared. Now, this is actually quite nice because a lot of things cancel. Cancel, 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 cancel. So now I get 3 times 0.2 plus x squared equals 5x squared. 0.04 times 3 plus 0.4x plus x squared equals 5x squared. 5x squared minus 3x squared is 2x squared. Minus 0.8x minus 0.12 equals 0. What could I do to clean this up? I don't like these decimals. This is 4/5. Yeah, hang on. Yeah. 3 times 0.04 is 0.12. Oh, thank you. That should be 1.2. Thank you. Actually, that's better because I can multiply everything. I can multiply everything by 100 and then divide 200x squared minus 120x minus 12 equals 0, and then divide everything by 5, no, 6, no, 2 just? 100 minus 60x minus 6 equals 0. 2 again. 50x squared minus 30x minus 3 equals 0. Now I don't, because I made up the numbers, I doubt that this will have nice roots, so I won't even bother with considering the negative because I said x should be positive. So it's minus b plus or minus the square root of b squared minus 4ac all over 2a. So that will be roughly 30 plus, I'm only going to look at the plus, 50.5 over 100. Thank you. Let's see how close I get it. 80.5 over 100. So that's roughly 0.8, about 80.5 centimeters roughly. Is it? Oh, it's 87 millimeters.
0.6.
That's what I said. 0.687, right? That's exactly what I said. Thank you. Is this one okay?
Well, what's the other one?
Well, at the beginning I said x is positive. Because the other answer will put you in this region, which we said doesn't have an equilibrium. And in fact, when it moves into this region, the signs get flipped on this because the direction changes, so it's not valid. Is this okay, folks? Is that a yes? I'm worried that you're thinking too much about this. No? I'm not. No, you're writing down KJ. It's okay. Where's Sean? Did you not have class at 9? Is your first class? Whoops. Oh, we got the new TV for this room yesterday. Yeah, we're going to put a TV in this room so we don't have to use the projector. So I got the TV and the ceiling mount to mount it on the ceiling. So we're going to put it in the corner here.
Like that?
Well, you can turn it because the ceiling mount is adjustable. It's a 43 inch. Pretty big. 43 inches is like
How much
this.
is it?
Is it 43?
For a school, not a cinema. It's big enough for this classroom. Yeah.
Only for this classroom.
Well, if it works well, we'll get it for other classrooms. I suggested that we do this instead of using the projector, because then I can just connect it to the screen, and it'll probably be a bit clearer too. So the price is, I think, $550. Huh? How's it a trial? I'll still use it. It'll still have a place in my heart. Okay, continue. Yeah, chew. Yeah. Okay, so we looked at old field questions, but more usefully now, let's look at new ones. What the recent examiner has been asking. Mechanics. Yay, Kirchhoff. Atoms, which we haven't done. Fields. And this question is a mixture of gravitational field and electric field. No magnetic field in this one. And this one here is a wave. So we'll do question 4, but let me just see. I wonder if section A had a magnetic field question. No. No. Yes. Let's do this one in our head. A long straight wire has a current of 6.58 amps and it's at an angle of 70 to a field of 0.357. What is the force if the wire is 1 meter long? So what formula is this? F equals Bill, but we need a cos or a sine, don't we? And no problem if you forget, because if you simply scroll up to the formula book, you can see it's sine. So as long as you have a calculator, fingers and a brain, you can simply push all the numbers and get the answer. Easy peasy, 2 marks. B times I times L times sine theta, bash it in. You have both fingers and a brain and a calculator. You have all 3. Give me the answer.
Still 2 marks.
Oh, come on. Just 2 marks. 2 marks for going. That's loads.
It's 1.81.
And the unit? What?
No.
What are you calculating? The force? Newtons. So little? Ah, no. What's too much? Just 2 marks. I will be so embarrassed if you type this in wrong.
What's the formula? Yeah.
Bill sine theta. Wait, did he do it wrong, KJ?
2.2.
OMG, Andrew.
Right there.
Oh, sorry.
Embarrassing.
Also, if this come out instead,
can I continue now with a real question? Okay, so.
Similar.
Yes.
By the way, if I get like degree of like 2.3 degree, then can I put some number and I change it?
After calculating the sign?
Yeah.
It has to happen before the sign.
you
You can't change it afterwards. 2.2
2.
newtons. Right, let's have a look at this question. I just want you to do part A. Now, part B is actually kind of difficult because you have 4 charges in 2 dimensions and you want to know in which direction will the field act. So something quite difficult is happening here. This is positive, so the field is coming out here. This is positive because the field is coming out. This is positive because the field is coming out. So when the fields combine here, they'll be stronger. But this is a negative. And when the field is pointing in, they'll cancel. In fact, if you really think about it, if you have a positive and a negative, and they're equal in size, then the field in the middle is 0 strength. Because will it move in the middle? No. So it's possible to have the positive and the negative, the fields cancel. And this question is a little bit tricky, and you can see, well, it's 5 marks. They want to know, in total, when you consider all 4 fields, what do they combine to form in the end as a single field? And that's quite hard. But before we get to that, let's start with a gravitational field one. So this is very similar to what we did recently. I'll make this a little bit. Part are you on, KJ? Huh? Great. Okay, folks, we should be coming to the, what part are you on, Monica? Okay, okay. Steady. Steady. Okay. Okay, let's have a look. So the first one, how can I get the omega? Just 2 pi over t, isn't it? And that's all fine and dandy. So the first one, part 1 here, I'm sure you already have it. Omega is 2 pi over t, but don't forget the t must be in seconds. And we have the t right here. It's this many days, isn't it? So what did we get here, folks? 10 to the minus 7 radians a second. Part 2. What is the linear speed? Oh, well, that's for babies, because we just have v equals omega or, which we now know, and the or we know, but just be careful, it's kilo, so we have to put in 10 to the 11. So what do we got here? You kept it as kilometers then? Yeah. Ah, so there's no need to convert this then, okay? Determine the mass. Okay, well, I think I'll just go with good old Kepler here. Go with Kepler, I think, here. T squared equals 4 pi squared or cubed over gm. So the m will equal 4 pi squared or cubed over gt squared. Bash in the numbers, and what do we get? Yeah, it's 1.99 times 10 to the 30. No, not 21, that's too small. 30 sounds right. You can easily check the answer, just Google mass of sun.
If I use GMM over I squared equals M omega.
So hold on, if you use what?
F
F? Tell me what you're using.
equals GMM I squared.
Correct, you could use this with another formula.
And
Yeah, you'd have to get the F. You'd have to use something like F equals mv squared over r. Because you know the mass of Venus, don't you? And you know the velocity, because they just asked you for that. Oh, but then it cancels if you make them equal. Oh, it does, doesn't it? Gm equals V squared, and the or cancels as well. No, but from one side. So actually, yeah, KJ, you're right. You could get this formula: M equals V squared or over G, and they just asked you to work out the V. Did you get the same answer? Well, let's check it here. What was the V, please? 35. Like this? KJ, I can confirm that you will get the same answer using this method for sure.
But if I use m omega squared r, then...
Hold on, now you're giving me a third way. Hold on.
If you go...
No, hold on. I'm writing. Okay. F equals GMM over r squared, right, fine. And you have F equals m... Fine. So GM over r squared equals m omega squared or. The m's cancel, and you get m equals omega squared or cubed over g. Right, let's check this answer. What was my omega in the first part, please? 3.24 minus 7. And then what was the or? Let me just... Come on. Yeah. Thank you. So we have not one, not two, but 3 ways to do this question. Wow. Okay, continue. What is the time taken for a satellite to complete one orbit of the planet at a height of 200 kilometers? Okay, I'll use Kepler again. Yeah? Okay, so using Kepler again, 4 pi squared or cubed, which will have a plus 200,000 meters. Because it says it's 200 kilometers above the surface of the planet. And what's the radius of the planet? 52 kilometers. And do they give me the mass of the planet? So the time in seconds? What did they say? In minutes. So that's seconds. So 90.8 minutes. Three significant figures, so I need the point here. Okay, 5. What is the gravitational field strength on the surface? Okay, so the formula for gravitational field strength is GM over... this is okay, so... okay, the M please again. 4.868 times 10 to the power... 8.86 newtons per kilogram. In the total for this half of the question, let's have a look. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 marks. 13% of the exam. Well, like I said, the fields question can be good and bad. Students think they're good at it when they're bad at it, but questions like this, I think, with Newton, they're actually quite good because they make use of circular motion formulas too, so they're not just fields. Like, think about it. Question 1 and 2 had nothing to do with fields. These were just usual circular motion formulas. V equals omega r, and omega is 2 pi over t. Okay, so now, like I promised, let's have a look at the B part, which is much harder. Define electric field strength. Okay, so what is electric field strength? Do we remember? Electric field strength is defined as the force per unit charge acted on by an electric field at a point. You notice every time you look at my definition, you'll not get the same words. That's not important. Where are the marks going? Well, how many marks is this? It's 1 mark. The key thing they will want to see is this part. Yeah, the force per unit charge. That's like the key magic words in the definition that they absolutely must see in your definition. Okay? The part 2. 4 charges are arranged as shown. What is the magnitude of the electric field strength at the center of the rectangle? So how strong is the electric field right here in the center? Let's have a look at that. Charge, how big is that one? That's a 2. 2 micro or 2 coulombs? 2 coulombs. Here, a 4 coulomb. Here, a minus 3 coulomb. And lastly, a 9. And it's 1 by 0.75. Okay. Now, they're looking for the center here. What did I want? The magnitude of the electric field strength at the center and the direction of the electric field at the center. Now, although this is broken up into 2 questions, for the way that I do it, it's actually easier for me just to do both parts at once. In other words, how big and where is it pointing? So, that's what I'm looking at here. Okay, so you remember the definition of an electric field is the force per unit charge. So just to make our life easy, I don't think they say how much of a charge is in the center, do they? No. So because the definition, and this is useful, because the definition is force per unit charge, if I just put a 1 coulomb charge in the middle, and if I calculate the force, then I'm also calculating at the same time the electric field strength, because the electric field strength is per 1 unit charge. So now my job is not get the electric field strength, now my job is kind of simpler, get the force. So, to get the force, I'll need to draw the forces. How many forces are acting here? Well, this is positive and this is positive, so this one will cause a push this way. Now, I have to be careful, it's not quite a square, so I shouldn't draw it pointing to the 9. It'll look like it's pointing to the 9, but it's just because the way I draw it. So I'll just draw it here. Okay, this one is from the 2. Right, what will the 4 do? The 4 will push it out this way as well. That is from the 4. So just to remind me, I'll just write letters here, A, B, C, and D. And this one is caused by the A. This one is caused by the B. Okay, where am I now? Here. That one is going to be this way. And that one's caused by the C. And lastly, this one here, the same as the B. Yeah. Now, I will need to calculate angles here because I'll need to resolve. So just on a separate diagram, I'll just draw the rectangle, but I'll just exaggerate it a little bit. So that is 1 meter, and that is 0.75 meters, and the center would be right here. So actually, I'm sorry, I guess I misspoke earlier. When this pushes away, I think it would push it exactly along diagonal to the other side. So my next job is to get the angles here. If I look back here, what angles do I want? Well, let me just draw in an X and a Y. So there's the Y, there's the X. So what angles do I need? I would like this angle, but that's nice because that's the same as this angle. And then I'll also need to get this angle. So I need to get 2 angles. Basically, I need to get this angle and this angle. Well, if that's 0.75, then the middle here will be 0.75 over 2. What's that? 0.3725? What is it? 0.75 divided by 2? It's 375, yeah. Okay, so this angle here, I'll call it alpha and beta. So alpha is tan inverse. This side here is 0.5. So it's tan inverse 0.375 over 0.5. In degree mode, Andrew, can you give me this, please? And then beta will be tan inverse. Is it going to be the same? They're going to be the same angle? Great. Yeah, okay.
36.9.
Okay, so since these 2 angles are the same, I'll just call them both theta. Back to my picture. So that's a theta, that's a theta, that's a theta, and that's a theta. There's 2 vectors there. Now I'll need to resolve. So let me just look firstly left and right, okay? So what is the total force to the right? That will be this one minus these 2. So it'll be cos, I'll write FA cos theta minus F, what'll be next? B cos theta minus FC, D cos theta. Now because all the angles are the same, that's nice. That will just be cos theta FA minus FB minus FC. How do we get the F? We need to use Coulomb's law. So that will be K. Yeah, Q1. Now, again, it was nice that I chose the 1 here because it means there's always a 1 in the top. So Q1 will be 1. So I only care about the other charges. So let's start with the A. What number do I have here? 9. All over, do I know the distance? I'll have to work it out, won't I? What's the hypotenuse here?
0.3.
It's the distance from here to the corner. Ah, yeah, but what's this here? It's square root this squared plus this squared.
Don't have to.
I want to. Let me. 0. If you don't mind. Yes. Oh, thank you, Monica. I was looking at the wrong one. Yeah, it should be K2 over, what was the number you just got? 0.625 squared. Minus 4 times K over 0.625 squared. Minus 3. Yeah. I've already taken care of the minus by the direction I've drawn it in, so I don't want to put another minus in because that would make it wrong then. Yeah. Over 0.625 squared. Right, okay, so let me see. this should be, well, if it's positive it means to the right is bigger, and if it's negative it means to the left is bigger. So 2 minus 4 minus 2 minus 3 is minus 5. So this will be minus 5k cos theta over, well, let me put in the numbers, cos, what was it, 30 something? 36.9 over 0.625 squared. And the k we actually know, remember it's 8.99 times 10 to the 9. Do you mind hitting that in and giving me that, please?
Negative 9.20 times 10 to the power of 10.
9.20 times 10 to the 10.
Yeah.
Newtons per coulomb. 10 to the 10? So big. Oh, minus 10 here. Whatever. Okay. Next and finally, F up. Now you can see what's going to happen. It's going to be something similar. What forces are acting up here? It would be FC. And what two are acting down? Or three are acting down? B, D, and A. Yeah, but this one will be a sign, this will be a sign, this will be a sign, this will be a sign. So all of them will have a sign. Let me just take the sign out right now. And it will be FC minus B minus D minus A. Now once again, what will they all have in common? The K will be in common and the R will be in common. So it's just to save time, I'll say this will be sine 36.9 times K over 0.625 squared, and then this will be C minus B minus D minus A. So what's C? It's 9 minus 4 minus 3 minus 2. Oh, is that 0? Nice. So it's 0 newtons per coulomb. So putting these results together means in this picture here, in the middle, the electric field is only acting to the left. Now if it wasn't, if we had another answer, for example, imagine that it wasn't 0, instead it would say something like this. Well then, all we have to do is get the magnitude and the angle, because that's what they asked for. They said, what is the magnitude and what is the direction? But in this case, it actually worked out a little bit nicely for us at the end, because it turns out that this one here is a 0 newtons per coulomb, and this one here we said is a 9.2 times 10 to the 10 newtons per coulomb. So the final answer is the field will act left with a total strength of 9.2 times 10 to the 10 newtons per coulomb. Now that's a lot, but that is 6 marks. And it'll be extremely easy to make a mistake, and I'm scared to look at the answer. Oh no, don't worry. We said earlier when we did this that the epsilon 0 in the formula is a constant. Technically speaking, it's not. So they're just reminding you to assume it's the constant on the calculator. Oh, I'm scared to look. Okay, be brave, Stephen. Which question is this? Is it?
Just recording.
It's recording. Which one?
Boom.
Hold on. Leave me be.
Boom.
Well, hold on. Where's the answer? No. The angle's right. 2.58 times 10 to the 5. Where's the... Oh wait, that's not finished, sorry. From P towards AD, and parallel to BA. So, I have the direction right, to the left. Do I have the strength right? Now just remember, he gave me the number.
Yeah.
Okay. Are you going to tell me it's wrong?
No, it's good.
9.2 times 10 to the 10.
Boom.
It says here 2.58 times 10 to the 5. Now, they added these two together. That's what I did as well, isn't it? No, I added, oh no, I had three things. Oh, but they might have added things earlier. Oh, japers, there's a lot going on here. Just give me the answer.
Oh, that's good.
It's kind of you to say that, and that is possibly true. I don't feel like I went wrong because I got the right direction at the end. It'd be quite an amazing accident if I got the wrong magnitude but managed to work out the right direction afterwards. Well, they did it slightly differently. You want to have a look? They got AC, they got AP. The K is 8.99 times 10 to the 9, isn't it? Isn't that what I used? 8.99 times 10 to the 9, or is it? It is that, isn't it? But they keep getting 10 to the 5s everywhere, and I'm getting like 10 to the 10s. Not that I don't trust you, Andrew, but let me just type it in here. Minus 5 times 8.99 times 10 to the 9 times cos 36.9 over 0.625 squared. Yeah, okay, I trust you. Yeah, but I want to know which of my numbers went wrong, or is it their mistake? I don't know, not now. We only got one class. What do you need up? The answers. You see, they do things like I do. They subtract here.
Oh, the minus. Isn't it minus?
No, because I already have the minus in the direction. I have it pointing the right way. You know, like here, you're saying, is it to do with the minus on one of these?
Yeah,
like, for example, the tree. This minus is correct because I needed to take away from the A. The direction is already correct. If I put another minus in, it'll make it wrong. In the formula, it'll add instead of subtract. This one is A, isn't it? No. Huh? Say again, Monica? Yeah, 9 minus 2. Where's the 9? They did 9 minus 2, so they did that. They must have done this separately. 4 minus 3. Now, I feel like that's their mistake. No, but the 4 and the 3. The 4 is here. That will push you to the left or to the right. The 4 will push you left or right if you're in the middle here. Oh, wait. Yeah, I'll put you to the left.
Let's try.
No, listen. Will the 4 push you left or right? Left. And will the minus 3 push you left or right? Left. So, it doesn't matter if I use minus or plus, we both agree that this should be the same sign. So I have the same sign here, I have minus 4, minus 3. They also have the same sign, 4 plus 3. But they just need to take this away from the other answer, because they're acting in opposite directions. From this. The 9 is opposite. The 9 is the 2 makes you go to the right. Do they? Where? Yeah, 9 minus this 2. And the 4 minus 3. Yeah, but the question is, how do you combine this and this? But they keep getting 10 to the 5. I'd be so angry if I got the K wrong, if that was the only reason. (8.99 times 10 to the 9). Maybe they got it wrong. -6. I don't know. I'll have to look at this in detail and look at my answer in detail and see. We can't both be right. My answer is 10 to the 5 times bigger than their answer. There must be... It can't be something as stupid as the sign is wrong, because the wrong sign wouldn't make my answer 10 to the 5 times bigger than their answer. So it's going to be a constant somewhere. The K is right. It's in the formula book. There it is there. The 1 over 4 pi epsilon 0 should be the same as that. No, I guess we'll just have to discover some... I see. It's their mistake. In their picture, they forgot to write micro. These are all microcoulombs. Look. 10 to the -6. That's why my answer is 10 to the 5 bigger. So it's their mistake because they never put in the picture. There's a micro. Oh, that's why there's a space here. There should be a micro here that didn't print. So technically, if I was a student, I did it right because I used the information presented to me. It's their answer that's wrong. But I'm happy that we know what went wrong then. If this was an exam situation, I would still give you the full marks because it wasn't your fault that the micro didn't print on the page.
How do you know?
How do I know what?
We get back our...
Huh? What are you asking me? How do I know? Yeah, I marked them, and then I sent it to them for them to mark. So I have to write a report. In my report, I would say there was an error in this question. The following students are affected. Yeah. Okay, good.